All right. So let us discuss about definition of Z bench. By default, these are the values that we get. So let me highlight those. Probability of defects relative to LSL, that is 5%. You get Z value as 1.64. Probability of defects relative to USL, that is 25%. You get Z value as 0.67.
How we are getting this?
By default, we get it. These values you will have to remember, or you can refer to the table. A Z value taken from normal table corresponding total. So Z is 52%. So how are we getting these values, right? So let us look at this 5%, 1.64. Let me go back. The 5%. Uh, 0.0. I'll just confirm this, Anuj. Just bear with me on that. I'll just tell you on how to look into the Z distribution, Z tables. There is Z distribution table, which I'm going to send across. And we'll be easily able to identify the probability of defects less than 0.05, so on and so forth. So I'll anyways explain that. So we have discussed multiple times about what is sigma level. We have discussed about sigma long term and then sigma short term as well. Sigma long term is we collect enough data, we find percentage defectives, and then we find the Z value. So Z long term is if I want to find out my sigma level for say the next 1 year or 2 years or 3 years or 5 years or 10 years for a long duration, then it will be called as long term. If I'm calculating only for 1 day, 2 days, 5 days, 1 month, so on and so forth, it will be called as sigma short term. Do rational subgrouping of the available data. I've told you what is a subgroup. If I'm manufacturing Coke bottles using 100 machines, then the Coke bottles which are coming out of each machine would be called as one subgroup. And we find the sigma for the best subgroup. And assuming that the process mean shifts by 1.5% or sorry 1.5 sigma, we have this sigma level short term is equal to sigma level long term plus 1.5. All right. So are these numbers and these things clear, Anuj?
Yes, so far okay, but I think when it comes to practically,
So practical.
I remember this. I remember this. Yeah.
Yeah. All right.
In Greenbelt we did. Yeah.
Yeah. All right. Short-term and long-term performance. Variability in output when most of the inputs affecting that output are held together. That is short-term variation. So here are the types of data collected. Short-term data will give you short-term performance. If you collect sigma level short-term and DPMO for short-term, which are calculated directly from data, you get short-term data and short-term performance details. If you want long-term data and short-term performance, then you calculate same sigma level short-term and DPMO short-term using 1.5 sigma shift. And when it comes to long-term performance, sigma level long-term and DPMO long-term are estimated using 1.5 sigma shift. And if you want long-term, if you have long-term data and if you want to calculate long-term performance, you can directly calculate this. Okay, just remember this.
This is something which I have to remember, or it will come.
You'll have to remember all these things. Okay.
We can in the real life, when the project comes, we can use books and those kind of materials, right?
Yeah, in real life, what they will ask you to do is, where do I stand as of today? They'll ask you this question. You're telling you will implement Six Sigma, fine, but what Sigma level is my process currently running at? They'll ask you this question. So how will you tell them what is the current level? What is your current performance? How will you tell any company that you're operating at this level, so let me take you to Six Sigma level? Yanush, how can you tell that? Because you are operating at only 3 sigma level or 3.5 sigma level or 4 sigma level. How can you say that? By calculating your Z value. Yeah, in practical terms, you calculate the Z value and tell the company that, sir, as of today, you are operating at 3 sigma level or 4 sigma level or 5 sigma level. Yeah, very.
When you say calculating the Z value, means the Z value which we did in the green belt, right?
Correct, exactly. In practical terms, I'm telling you that company will ask you, it's fine, Anuj, that you want to take a company to Six Sigma level, but what Sigma level do we stand as of today?
And those things which we will be, I'm hoping, will be practicing during the project as well, right?
Okay, let me ask you this question, Anuj. If someone is going to ask you what Sigma level you are operating at currently, then how do you calculate? What do you calculate?
The Z value.
Absolutely. Your job is done. So for this, what practice do you require? In green belt already we have done, I think 8 exercises.
Yes, I know.
Right? And here we'll be doing many more exercises. So for just finding out Z value, we need not do any project. We just need to be aware of this concept and the application of it. That's it.
Okay.
Yeah. So look at this table. If you have continuous data, then you ask one question. Is the data short-term data that I have or long-term data? Short-term data means your company has been operating since 10 years, but you have data only for 4 months or 3 months or 2 months. Short. You have very small data. Short-term data is what you have. If my company is operating since 10 years and if I have data for all the 10 years, it will be called as long-term data. Right? If you have this short-term data, you'll have to calculate short-term sigma level, convert it to estimated long-term DPMO. We'll do these exercises now. On the other side, if you have long-term data, you calculate long-term sigma level, convert it to long-term DPMO. Then actual short-term sigma level can be found if there is valid subgrouping. Estimated short-term sigma level shall be used if there is no valid subgrouping. Just remember for now, we'll do the exercises on this. Then for attribute data, you have short-term and long-term data. If we have short-term data, you can calculate short-term sigma level or convert to estimated long-term DPM, defects per million opportunities. If it is long-term, then you calculate long-term DPMO, convert to estimated short-term sigma level. Simple. So ultimately, you need to find out what sigma level and also DPM, defects per million opportunities. So whatever data is given to you, you can easily calculate the other details. So let me move on to the next slide. How do you calculate the sigma level? For continuous data, you want to calculate the probability. P of D means probability. Probability is equal to probability of upper and probability of lower. So put it in this way and put your upper and lower level. This is the probability of upper. And this is the probability of lower. For continuous data, you do in this way, and then you calculate DPMO. DPMO is nothing but probability of a point multiplied by 1 million opportunities. Once you get this DPMO, you can also get your ZLT. ZLT is nothing but Z value of probability. That's it. This is if you have long-term data. Once we do exercises, things will become clear. Until then, you can just remember these things. Then if you have discrete data, in discrete data, we know for a fact that we have two things. We have defective data and defect data. If you have defective data, probability is 1 minus FTY. What is FTY, Anuj? Do you remember by any chance? Yeah, Anuj?
Sorry. No, sorry.
Yeah. Do you remember what is FTY?
No, I'm just trying to remember.
First time yield. First time yield.
Oh, yes. Yes.
And
Is
then
it
calculate.
something noise coming from my end?
Sorry?
Is it something too kind of noisy from my end?
I didn't get you, Anuj.
Is it noisy from my end?
I have 100% volume. Still, I'm unable to hear you. Can you be a little loud, please?
Can you hear me now?
Yeah.
Okay, I'm just wondering, is it noisy from my end or is it okay?
Can you type that, Anuj? I'm unable to get you.
Okay.
Oh, no, Anuj. No, it's not at all noisy from your end. You have muted it, right? So I am unable to hear any noise as well. Is it okay if...
Can you hear me?
Yeah, I can hear you.
Oh, good. I'll put you in mute now, okay?
All right.
Yeah.
So the calculation of ZLT would still remain the same. Yeah, we just calculate the Z value of probability distribution. Then in discrete data, we also have defect data. If defect data is given, how do you calculate the FTY? FTY is equal to exponential E to the power minus DPU. Minus DPU. If you want to find out FTY. Once you get FTY, probability is nothing but 1 minus FTY. Then you calculate DPMO and then you calculate ZLT. And ZST we know that is ZLT plus 1.5 or Z of bench plus 1.5. Alright. Calculating sigma level. If number of defects is given, first calculate DPMO. Find ZLT from the table or Minitab. If the yield is given, check if rolled throughput yield is taken for the whole process which is considered. Check if it excludes all reworks or scrap. Find number of good products in 1 million. Find ZLT from the table or Minitab. In case of percentage defectives, then you find DPMO, which is percentage of defectives multiplied by 1 million. Then again you calculate ZLT from the table or Minitab. So we'll do both of these things. From table also we'll see how to calculate ZLT and also from Minitab. How to calculate yield to sigma level? How do you convert that? We know that we have yield, first time yield. First time yield is number of good units through the first time divided by total units. Number of good units that we have for the first time divided by total number of units. Yeah, rolled throughput yield is multiplication of first time yield of all the multiple steps. And then we have yield normalized. Equivalent yield at each step that provides the same RTY. So if you see this, here it is, first time yield is 90%, first time yield of step 2 is 80%, and first time yield of step 3 is 90%. So if I multiply all these three, I'll get rolled throughput yield, which is equal to 64.8%. If I want to calculate normalized yield, then I just do a cube because there are 3 steps. If there are 2 steps, then this normalized yield would have been like this. Normalized yield is equal to 0.648 whole to the power 1 by 2. If we had 4 steps, this would have been 1 by 4. If we had 5 steps, it would have been 1 by 5, so on and so forth. And from this, we can easily calculate the DPMO. With the use of INA, if we want to calculate the DPMO, we'll get so much, which translates to Z value of 1.1. All right. Here comes our...
Sorry.
Yeah, no. Now we are starting with the exercises.
Okay. Because the last thing...
Yeah. We are starting the exercises, so how to calculate each and everything will become clear now. So just take a shot at this, Anuj. Take a shot at this. Try to get to the values, and then we'll discuss. Just take 5 minutes. I just want to see your thought process also on how you are approaching this question. So this is how the questions will be in real time also. So just try, open your PDF and try to solve this. We will just solve this. All right, Anuj. Any guesses on how to solve this?
Can you hear me?
I can hear you.
Oh, good. I'm just wondering, first we need to find out how many pieces are non-defective, right? So.
Okay. Do you remember the sigma level calculator which we have used?
Yes.
Can you just open that once?
Give me just 1 minute. It will be in my...
And can you also share your screen?
But the issue is, can you have a look? I will hang on.
Okay.
Can you give me the control?
Okay, I'm doing
Hello.
it. I'm doing it. Yep. I've given you the control.
Can you see my screen?
Yeah,
Can you see my screen?
but still it is a blank screen. All right, give the control back to me. I'll just show you once.
Yeah, okay. Did GoToMeeting people get back to you or not yet?
No, they have responded that problem is not from their end.
Oh, is it? Is everything is okay from your end today? It looks like...
Yeah, no, because there are other participants also, right, who are connecting. So they do not have any issues actually. I also have them share their screen, but that's working fine.
Okay, then let me check from my end. Yeah, okay.
Yeah. So let me know once.
Yeah, okay, sorry. Is everything is fine from your side today?
Yeah. No, I'm speaking slowly because there is a class which is happening just beside our training room as well. So.
Okay. Because your voice is with a different sound today. So, because I have a very rough face going on. So.
One second, Anuj, I'm opening sigma level calculator.
Okay.
So what is given to us, Anuj? I'm opening this. What is given to us? They have given us the defects, number of units, that is a sample, and opportunities for error is also given. So now we let me go back to the. Are you able to see my Excel sheet?
Yes.
Okay. So defects, sample, and OFA, opportunities for error, is given. So let us first calculate defects. 2,500, 10,000, and 5. So 2,500 defects out of and 5 opportunities for error is given. What is a sigma LT? It is 1.64. Yeah, this is how we simply calculate. Now we have department B also. Here we have 8,000 defects out of 9,000 units produced, where each unit has 4 opportunities for defects. Alright, so simply again I'll go back to the sigma level calculator. So they are telling 8,000 defects in 9,000 units, and there are 4 opportunities for error. Sigma long term is 0.76. Simple. Is this clear?
Yes.
Let us calculate the sigma level even for this. Using continuous data, the long-term DPMO is calculated as 2 lakh. Calculate the long-term and short-term Z values. What are we given? We are just given the long-term DPMO. So let me go here. They have just given the DPMO. That's it. We know only DPMO. What is a DPMO? 200,000. If I just insert that, I'm getting the sigma long term and short term, which is 0.84. So the first one, long term, is 0.84, and the short term is 2.34. Sorry. Look at this one. Using defectives data, the long term yield is given as 95%. Only yield is given to me, right? I need to calculate the sigma level, that is Z values. Simple, I've put that yield there and I'm getting sigma level as 1.64. Third thing is using defects data, the average defects per unit is given as 0.02. Only DPU is given, defects per unit. Defects per unit is given as 0.02. If only this is given, if I want to calculate the sigma level, then it will be 2.06 long term and short term is 3.56. Was it clear, Anuj? How to calculate? Simple. Use sigma level calculator.
Yeah, thank you. Yes, it is clear. Yeah, thank you.
Yeah. So let us also discuss about process capability. Here are the 4 formulae that you have to remember or by heart in order to calculate your CP, CPK, PP, PPK. In Six Sigma Green Belt, we have calculated only CP and CPK. In this, we will be calculating PP, PPK also. These 4 are called as capability indices, right? They are matrices that can be used to quantify the capability of process. To obtain these indices, the process performance is compared with the customer requirements, right? So your customer requirements are USL and LSL. Okay. What is CP? What is CPK? What is PP? And what is PPK? CP is potential process capability index when process mean is equal to specification center. As I've told you, what is CP? If suppose this is the dartboard and this is the bullseye. If continuously I'm hitting my points here, if all my data lie here, then I can say that CP is high. Why? Because the variation is less. Yeah. When variation is less, I call it as CP. What is CPK? CPK is potential process capability index when process mean is not equal to specification center. That means, in again, going back to a Six Sigma thing, in addition to that, we are actually looking into the other things. CPK means how close is your mean to the target. Now CP and CPK are speaking about potential process capability. That means my process capability might be so much. That is potential. Right? But PP, PPK are actual process capability index. So if you have all the data with you, all the data on the planet, if you have the data with you, then you use PP, PPK to calculate your capability indices. But if you have very less data available with you or if data is not complete, then you take CP, CPK to define your process capability indices. For now, you'll have to just remember these 4 things. I'll give you just quick 1 minute, go through these. Because now we have calculations, problems. All right, Anuj, have you looked into that?
Yes.
So
Yes.
please calculate CP, CPK, PP, PPK and tell me what are those values. Either use sigma level calculator or use manual calculations, but calculate and tell me what is CP, CPK and PP, PPK.
1 minute, okay?
Sorry, Anuj, what did you say?
USL minus LS. No, USL minus LSL.
Divided by
21 divided by 6 times standard deviation. US, there are two. You can hear me, right? Hello? Ravi?
yeah, Anuj. Sorry, I put you on mute because I thought you'll take some time to calculate these values.
Yeah. So my understanding formula for the CP is USL minus LSL divided by 6 times standard deviation, which comes to
Yeah, Anuj. So Anuj, these formulae are given in the PDF that I've shared with you.
Yeah.
So can you just open that and it's a direct formula application. Just apply that formula and calculate the values and tell me.
Yeah, okay.
Yeah.
My God.
Anuj, were you successful?
Actually, my PDF is hang up sampling menu.
All right. I'll do one thing. I'll just quickly show you how to calculate. You remember these values?
Okay. Sorry for that.
No problem.
Yeah,
No
sorry.
problem at all. So let me do this. So it's simple.
I remember USL minus L divided by 6 times.
Yeah. If you ask me, I would calculate in a different way. How would I calculate CPCPK or PPPPK? I would simply put these values here. 29, 21, 29, sorry, 29 and 21. What is the mean? Mean is 23.495. 23.495. And then standard deviation short term is 4.1604. 4.1604. Yeah, if I calculate that CPCPK, what is it that I'm getting? 0.32 and 0.19. This is my CPCPK. If instead I change this standard deviation to long term, that is 4.447. Then CP-CPK would be called as PP-PPK. Simple. Yeah, no, so I'll simply go to this and do it if I do not have sufficient time with me. If I have sufficient time with me, I will probably do a manual calculation using these formulae. Simple. Everything would remain the same except for
Understood.
Yeah.
Okay.
Yeah, but in real world, people will not give you time to actually do all these manual calculations, right? They want quick responses. In order to give them quick responses, we use these kind of sheets wherein formulas are already embedded. All right. Data types. If you have continuous data, then you can calculate capability analysis if the data is normal. And if the data is not normal and if it follows Weibull distribution or exponential, you use others. This Weibull exponential and all, Anuj, after our black belt, I'm going to give you all these files. I would request you to just go through all the distributions and understand the inside out of these distributions. You know, these will be used extensively in our master black belt. So if the data type is attribute data, then you use two types of capability analysis. One is binomial, another thing is Poisson. All these things will become clear to you. Just bear with me until now. So how do you calculate capability, process capability for normal data? That is the first question. So these data points, Anuj, these data points 24.1, 0.2, 29, 18.6 and all these, day 1, day 2, day 3, day 4 and day 5, you're going to enter it in Minitab. Anuj, let me know if it is a little exhaustive. I can probably stop and then we can do it tomorrow also. If you are okay, I'll continue.
No, it's okay to continue now.
All
I will
right.
let you know.
Yeah, sure. No
Thanks.
problem. No
So
problem.
from your end?
Sorry? Yeah, I'm fine. I'm fine with that.
Okay. Thanks.
So let us consider this example. The following is data measuring length of 50 samples of an auto part. Yeah, 50 samples. If you calculate, there will be 50. Right? 10 samples each. This will be 10. My bad. This count will be 10. This count will be 10. 10 data points or 10 samples each for 5 days. Yeah, were captured to analyze the process capability. Data was found to be normally distributed and specifications given are 25 plus or minus 4 centimeters. So Anuj, by looking at this particular thing, can you tell me what is the USL and LSL out of that?
USL. Sorry, USL is 29 centimeter and LSL is 21 centimeter.
Absolutely correct. You're right on that. So we need to calculate the capability. So this is how we do. I have already shared those files with you. You can just open that Minitab file. Okay, let me also do, you need to go to start, quality tools, capability analysis, normal. The navigation is also given. You have told me that LSL is 21 and USL is 29, which we have marked here. And then we select those columns, length and day. But this is what we get. Simple, on a click of a button, I get all these things. Process data summary. Here you'll get mean, standard deviation for within and overall. Within is for short term. When you speak about overall, it will be for long term. This is short term and long term. Potential capability within. Within is Again, short term. So CP, CPK values are based on within process performance. You get CP value as 0.32 and CPK as 0.20. Then PP, PPK values are based on overall process performance. Overall, how is the process performance? PP is 0.3 and PPK is 0.19. Yeah, and also there are few more things that are given here. One is actual raw data points that are outside the specification limits. How many points are falling outside the specification limits? Those details you can get from here. Based on area under this red curve, there is a red curve there if you notice clearly. There's a black dotted line and a red line. Yeah, based on area under the red curve, which is outside the specification limits for a normal distribution with mean so much and standard deviation so much. Yeah, and if you look into this, within, overall is long term always, overall process. Within is for the short term. So based on area under the dotted black curve outside the specification limits, you get these values. For same thing, here also you'll have the same mean, but here it changes. Here you get the overall standard deviation. And then let's use Minitab to estimate the short term and long term sigma level Z values. How do you get these Z values? Once again, you do the same thing, that is, you go to stat, quality tools, capability analysis. My bad, let me actually make this small correction. It is stat in Minitab actually. Just a minute while this saves. All right. So once you do that, you get this box, this particular, one second, you get this particular box. Once you get this box, you click on options. Once you click on options, you just select this. Not just capability, I want to come up with the sigma level, Z value. Once you click that, you start getting the Z values immediately. You get Z LSL, here it is. Then you get Z USL, and as I've told you, overall means long term. Right? Within means it is for short term. Yeah, this is how you calculate if you want to calculate using Minitab. And Z entitlement. Z entitlement for normal data. All you need to do is go to stat once again, basic statistics, display descriptive statistics. Once you do that, once again, am I recording? Yes. All right. Once you do this, you will get the below details. Let me put it here in the slideshow. Yeah, you will get these details. Once you get these details, you pick up that standard deviation, which is the smallest. This is the best subgroup with the smallest standard deviation. Use this to compute the Z entitlement. So let me see how to calculate Z entitlement. When I calculate Z entitlement, I get these values. Yeah, and Z entitlement is nothing but your, Z bench. Z entitlement is nothing but your Z bench. And look at this, I have changed the standard deviation to 2.611. If I go here, this is what is 2.611. I use that simply and then I'll get these values. Based on our analysis, these are the values that we have got. Yeah, we have got Z long term as 0.27, short term as 0.34, and Z entitlement as 1.15. And the corresponding DPMO values also we calculate. And for a 50% reduction in defects in a question, we need the DPMO to drop to this level. From this, 50% of that would be 196525. This corresponds to a Z goal of 0.85. So now when I actually discuss about how to find out these Z values and DPMO values from the table, then things will become clear for you. Okay, so let us for that case do this so that things are clear. Z value is 0.27. How am I making this statement? If the Z value is 0.27, how do you comment that DPMO is 393051? We don't want to do all the manual calculations because in real time we will not be given so much of time. So how to calculate this? So let me take you back to the sigma table, sigma level table, and just remember this 0.27 and 393051. So what is the sigma level that we are planning to calculate, Anush? Can you tell me? 0.2?
7.
Okay, here we have 0.2, but we want to calculate for 0.7, 0.27, right?
Yes.
0.27. 0.2 is here. Where is 0.07 here? So if I go like this and like this is the value that we'll be getting, DPMO. Yeah, tell me if you have any doubts. I'll tell you. I'll clarify.
No, I don't.
You did not understand. Okay.
I understand now. Understand.
You understood.
Any slow, yes.
0.27. Here we have 0.2. Here we have 0.07. If I add these two, 0.2 plus 0.07, I'll get 0.27. Hence, that corresponding value will be my DPMO. DPMO. Defects per million opportunity. So let me ask you another question. What if it is 2.57 Z value? Then how do I calculate the DPMO? Can you tell me what the DPMO
2 is here. 2.
So you're telling 2.5 is here.
Yeah.
You want to calculate
it's 5.
2.57. Yeah, 5085. Absolutely correct. Here it is. Yeah, correct. You're right. Yeah. So that is how you need to read that table. That's it. Yeah. We got approximately those values only here also. Yeah, that is how you calculate. What if the data is not normal? What do you do if the data is not normal? All right, if data is normal, it's very easy.
Can we stop, or if you want, like, can we stop here?
Yeah, we will just stop here in that case.